Recording experiment 5 determine left. So uh, this is the first part of the question. So in here we first imported data set called 3D from the file. So we have imported and we need the package called ca-tools. So we import that one. Then let's see the imported data using the head function, and this is the imported data. This is the first 6 rows of the imported data, which are X, Y, large quarterly revenue, the price index, the income level, and the market potential. So what we're going to try to find here using the LM function is to find out the market potential, and we want to use the quarterly revenue and the price index and the income level to in the formula. And also, yeah, so let's see the set and a summary of it. Yeah, this is a summary of it, and it gives values like mean, multiple R square value, p-value, and yeah, all this information. These are the intercept is basically the constant in the formula, and the resultant linear equation, and these are the coefficients for each attribute. So now to do it using the training and dividing the data set into training and testing, this is how you do it. You take the entire rows, and out of that you take 70% of it. That's why you multiply it by 0.7, and you sample the data, and you have all the sampled row indexes in this particular variable. So if you put in this variable, you can see that this is a list of rows that are sampled, and all the rows uh, with the sampled index is going to go to training data. When you write minus training index, all the rows which were not sampled, that is all the rows which are not in training data, goes to testing data. And we're going to apply the same formula which we applied before and see the summary. And this is the result we have. It's pretty much similar. And let's see now we are going to try and predict using the test data. So the model we just created, we're going to apply to the test data, and we're going to predict some value. The predicted value is being stored in something called port prediction, and we're going to find the the error. So we're going to take the actual value minus the predicted value divided by the actual value, which will give you and find the mean of it. So and we have that, and yeah. Uh, Later what we do is we're going to plot what we found. So we're going to plot the predicted value against the actual value, and we're going to use the color blue and red in PCS16, and this is to put a line in the center. So let's see, and this is how to begin, and that's the first part. Now let's go to the second part. This is the second part where we're going to use the data set called classes, and we're going to import that into a variable called data. And out of data, we're going to take first 146 rows and 2 columns out of it. That is, yeah, 2 columns out of it. And okay, yeah, and we can also say the last one, that is the label, which is text. And you have that in data sub df. Then we import the ggplot to later plot um, the graph. So we have that. Now let's see it before. Okay, mm, let's see how it works now before we perform the function. And this is how the plot is. Now we're gonna take the fourth column alone, all the rows and only the fourth column, and we're gonna give it the value 1, and the rest of the values we're gonna give it the value -1. And you can print it out and see that, yeah, this is what happened now. Then later we're going to apply the perceptron algorithm. So this is the definition for perceptron algorithm, and it is basically what perceptron does. You take the weights and you take the errors, and you're going to use a loop and iterate through the loop, and each time you're going to find the weight, and you need to also find the z value. So based on the z value, you're going to check the condition to see if the prediction is -1 or 1. So the z value is calculated by the weight into the value and plus the weight. And after you compute the z value, you see what is the predicted YPRED. So, if it's -1 or 1, if it's less than 0, it's -1, otherwise it's 1. Later you're gonna make a difference in the weight, and the difference is eta, that is the learning rate, into the difference between the predicted value and the actual value, into um, into the numeric 101. Then you have the weight difference here, and the weight difference is later added to the weight. So if there is no difference between the actual and predicted value, then there is not going to be any increase in the weight difference, because it's going to be 0 here. So it's going to be weight plus 0, and later you compute the error by subtracting the predicted value from the desired value, and that is the function. So let's run the function once. So yeah, okay, sorry, yeah, we have it run. Now we're going to simply apply the perceptron algorithm. So x, y, 1 and 10 are the parameters we're going to. So 1 is the learning rate and 10 is the number of iterations, and x and y are basically the inputs. So here you can see x and y are the inputs which are provided from data subdf, and we have the error. Okay. Okay, let's run it now. Yep, we have the error values, and that is all. Thank you.